high-pass filter to do the sharpen, to sharpen the image. We also have the band-pass filter and a band-stop filter. This is the example for the low-pass filter. Say only the low frequency can pass this filter, and it will cut off all the high frequency part. It's for the blurry. This image is very blurry. The original image is this, and this is after you use the cutoff low pass filter. It's blurry, and this is the called cut-off low pass filter. Next one, we have another low pass filter. It's called a Butterworth low pass filter. Okay, give me a guess. Do you think this the image after this Butterworth low pass filter will be more blurry or a little bit better than the previous one? Yeah, it is a little bit better because this is not a straight line. It's not a cutoff. It is a curve, smooth curve. We have one more. It's called a Gaussian low pass filter. It's kind of similar like the Butterworth low pass filter. What about the high pass? It's a sharpen to only extract the information close to the high frequency edge. Okay, so you only see the edge from the image, right? And for the first one is the image, original image. This image converted to the frequency domain, just in this. And you do the inverse Fourier transformation on the original image. The second one, I think, is a low pass. It's blurry image, and only the low frequency can pass this filter. All the others cut off. And the third one is sharpen. It's a high pass. Only the high frequency can pass. The low pass will be cut off. So it's very interesting. So this is the image in the spatial domain. This is the image in the frequency domain. Image in the spatial domain. The image in the frequency domain. Okay. Okay, this is a band pass. Only a band signal can pass. A band of signals can pass. Band pass. Let me repeat what is a Fourier transformation if you still confused. If you're confused more formally. We want to represent the signal as an infinite weighted sum of an infinite number of sine waves. So we do the Fourier transformation to transform the time domain or spatial domain signal into the frequency domain signal, into the signal in the frequency domain. And this is called the Wooler formula. Okay? This is the Wooler formula. And then you also can do the inverse to convert the signal in the frequency domain to the signal in the time domain or spatial domain. You also can express the Fourier transformation in this way. There is no 2 pi. We have 2 pi here, but in other expression, we don't have 2 pi here, but we have 2 pi here. Okay? They are the same. They perform the same. This is some Fourier transformations for some typical functions like right angle function. The Fourier after transformation, the function looks in this way. The function in the frequency domain, and this is the triangular function in the say time domain, and this is the after the Fourier transformation, the function in the frequency domain. And this is exponential. This is the Gaussian properties of the Fourier transformation: linear arity, scaling, shifting, symmetry, convolution, differentiation. Okay. And discrete Fourier transformation. So in practice, we have just finite data lines, right? We need to sampling this signal using what criteria? Nyquist criteria, right? And then we also can do the discrete Fourier transformation, is a DFT, and this is the DFT spectrum. This is the properties of the DFT. And for the faster Fourier transform algorithms is optional, because you can just use the FFT in your MATLAB or FFT in R to do the transformation. You don't have to understand why. What is the principles between the function FFT? You understand what I'm talking about? You got the original signal. You sample it, then you use the MATLAB just FFT and the original signal, and you convert this original signal to the frequency signal. That is called FFT, is a method. If you're interested, you can read the slide. Okay, it is a smart method. I also give you some simple application for the FFT. You can simulate a random signal first, and then you can just do the FFT, okay? And this is the signal converted to the frequency domain. Any question? I think I already covered all the topics needed for Dr. Upadaya's class. FFT, Fourier transform, frequency, and the autocorrelation function, cross-correlation function, and more. And I need to cover this part for him. And the next Monday will be Dr. Kobo's active monitoring and the data analysis, and the Dr. Upadaya's vibration analysis. Then the last one is a lab maintenance lab tour, and then we are going to have a final exam on May 3rd. May 3rd, final exam online the whole day. I'll give you 1 day to finish this, okay, maybe 1 hour, 2 hours. We'll cover all the topics in this semester, from the first reliability, maintainability, maintenance, human error, economic ordering, replacement analysis, maybe basic principles of DSP, and some information from Dr. Kobo's lectures, from Dr. Upadaya's lecture, from our lab tour, but focus on the materials after the spring break. we are going to have one quiz in this week for the economic ordering and replacement analysis. Then we are going to have another quiz in the week of April 25th to cover all the DSP and the vibration analysis and active monitoring. Okay. Maybe the quizzes for the DSP and the vibration analysis will be more qualitative instead of quantitative. Ask you some basic principles. Like if I want to convert the signal from time domain to frequency domain, what transform we should use? Yeah, Fourier transform. And if I wanted to convert the frequency domain to time domain, what we need to use? The IFT and 1 RPM equals to 1/60 Hertz, and some trivial things like this. Okay. Any other questions? Yes.
Did you say that first quiz was going to be in?
Huh?
Not the second, but the first one?
You mean this week?
Yeah.
We have one chapter covered economical ordering quantity, and one chapter covered replacement analysis. We have 2 problems for quiz. I think it's quiz 3 or quiz 4 after quiz 3, and then the rest is a DSP and active monitoring and vibration analysis. Yes.
What is Project 2?
Project 2 is a field tour. Field tour, you register the Oak Ridge National Lab, you go there and you write a 1 page of report, submit. That is Project 2. And Project 3 is a lab tour. It's April 25th, 2 hours lab tour. Project 1 is a Macron conference. Any other questions?
When will you release this quiz this week? When will you release this week's quiz?
Excuse me?
When will you open quiz for this week?
I'm not sure yet. maybe Wednesday, maybe Thursday, or maybe Friday. Because he is quite busy this week. Too busy. Okay. Just 2 problems. Okay. Just 2 problems. One is calculate the economic ordering quantity. Another one is to find the minimum maintenance cost a year. You still remember that? It's engineering economics. I understand this the DSP part very very theoretical. I leave the rest of the time I will be here. If you have any questions, just come from and ask me, and I will try to help you. Okay. Any other complaints or questions? Okay, thank you.